Throughout history, humans have gazed at the starlit sky and pondered their place in the cosmos. Today, the most widely accepted explanation for the origin of the universe is the Big Bang Theory. This theory, supported by a wealth of scientific evidence, paints a picture of a universe that began from an extremely hot, dense state around 13.8 billion years ago. From this primordial soup of energy, everything we see around us, galaxies, stars, planets, and even ourselves emerged. Our understanding of the Big Bang has been shaped by decades of scientific inquiry, combining theoretical physics with astronomical observations. Join us as we delve into the fascinating history of the universe and explore the remarkable events that unfolded from the Big Bang to the present day. Imagine a time when our universe was an infinitesimally small point of unimaginable heat and density. Then, in a cataclysmic event, the universe exploded into existence. This was the Big Bang. At the moment of the Big Bang, space and time as we know them came into being. In the first fraction of a second, the universe underwent an extraordinary period of expansion known as inflation. During inflation, the universe expanded at an exponential rate, growing from subatomic size to a vast cosmic arena. As the universe cooled rapidly from its initial extreme temperatures, the stage was set for the formation of the first elementary particles. In the first few minutes after the Big Bang, the universe was a seething cauldron of elementary particles. Protons, neutrons, and electrons collided at incredible speeds, fusing together in a process called nucleosynthesis. As the universe cooled, protons and neutrons combined to form the nuclei of the first atoms, hydrogen and helium. These two elements, the lightest and most abundant in the universe, were forged in the fiery crucible of the Big Bang. The universe was filled with a sea of charged particles, a plasma that interacted strongly with light. It was only after the universe had cooled sufficiently for electrons to combine with atomic nuclei that the first neutral atoms formed, an event known as recombination. The expansion of the universe is a fundamental concept in cosmology, describing the ongoing stretching of space itself. This expansion was initially proposed to explain the observed redshift of distant galaxies, a phenomenon similar to the Doppler effect for sound waves. The redshift of light from distant galaxies indicates that they are moving away from us, and the farther away a galaxy is, the faster it appears to be receding. In the first fraction of a second after the Big Bang, the universe underwent a period of incredibly rapid expansion known as inflation. During inflation, the universe expanded at an exponential rate, increasing in size by a factor of at least 10 to the power of 26 in a tiny fraction of a second. While the exact mechanism driving inflation remains a mystery, it is a crucial concept in our understanding of the early universe. As astronomers observed the movements of galaxies and galaxy clusters, they noticed something peculiar. The visible matter in these structures could not account for the gravitational forces at play. There seemed to be some invisible form of matter, dubbed dark matter, exerting its gravitational influence on the visible universe. Dark matter does not interact with light or other forms of electromagnetic radiation, making it invisible to our telescopes. However, its gravitational effects are undeniable, holding galaxies together and influencing the large-scale structure of the universe. The exact nature of dark matter remains one of the biggest mysteries in modern astrophysics. Understanding dark matter is crucial for comprehending the evolution and structure of the universe. In the late 1990s, astronomers made a startling discovery that revolutionized our understanding of the universe. By observing distant supernovae, they found that the expansion of the universe was not slowing down as expected, but was actually accelerating. This unexpected acceleration implies the existence of a mysterious force, dubbed dark energy, that is counteracting gravity on cosmic scales. Dark energy is thought to be a property of space itself, a kind of cosmic anti-gravity that is pushing everything in the universe apart at an ever-increasing rate. The concept of dark energy is still poorly understood, and its nature remains one of the most profound mysteries in modern physics. The discovery of dark energy has profound implications for the fate of the universe. If its influence continues to dominate, the expansion of the universe will continue to accelerate, leading to a cold and lonely future where galaxies are increasingly isolated from one another. As the universe continued to expand and cool, gravity began to exert its influence on the distribution of matter. Tiny density fluctuations, amplified by the gravitational pull of dark matter, caused gas to clump together, forming vast clouds of hydrogen and helium. These gas clouds, known as nebulae, were the birthplaces of the first stars and galaxies. Within these nebulae, gravity caused gas and dust to collapse under their own weight, compressing and heating the material at their centers. As the temperature and pressure increased, nuclear fusion ignited, marking the birth of stars. Over billions of years, gravity continued to draw matter together, forming galaxies, vast collections of stars, gas, dust, and dark matter. Galaxies come in a variety of shapes and sizes, from spiral galaxies like our own Milky Way to elliptical galaxies and irregular galaxies. Stars are born within vast clouds of gas and dust called nebulae, stellar nurseries where gravity acts as a cosmic sculptor. These nebulae contain regions of higher density where gravity exerts a stronger pull. As gravity draws gas and dust together within these dense regions, the material collapses under its own weight, forming a protostar. As the protostar continues to accrete material, its core temperature and pressure increase. When the core temperature reaches a critical threshold, nuclear fusion ignites. Hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy in the process. The birth of a star is a violent and chaotic process, often accompanied by powerful jets of gas and radiation. Our solar system resides in a barred spiral galaxy called the Milky Way. From our vantage point on Earth, we see the Milky Way as a faint band of light stretching across the night sky. The Milky Way is estimated to contain hundreds of billions of stars, along with vast amounts of gas, dust, and dark matter. Its spiral arms are sites of active star formation, while its central bulge is thought to harbor a supermassive black hole. Our solar system is located about 2/3 of the way out from the galactic center, in a relatively quiet region of the Milky Way's disk. The Milky Way is part of a larger cosmic structure known as the Local Group, a collection of about 54 galaxies gravitationally bound together. When we look up at the night sky, we are looking back in time. Light from distant stars and galaxies takes time to reach us, so the farther away an object is, the earlier in its history we are seeing it. By observing distant objects, astronomers can piece together a timeline of the universe's evolution. Telescopes are like time machines, allowing us to observe the universe as it was billions of years ago. Understanding the universe's origins not only reveals its past, but also provides clues about its future. If the expansion of the universe continues to accelerate, the universe may eventually end in a big rip, where the very fabric of space-time is torn apart. However, other possibilities exist, such as a big crunch or a big freeze, where the universe continues to expand indefinitely, becoming increasingly cold and dark. The origin of the universe is a story of incredible energy, unimaginable scales, and profound mysteries. From the primordial soup of the Big Bang to the formation of galaxies, stars, and planets, the universe has undergone a remarkable journey of evolution over billions of years. While we have made significant strides in understanding the universe's origins, many questions remain unanswered. The nature of dark matter and dark energy, the ultimate fate of the universe, and the possibility of other universes are just a few of the mysteries that continue to intrigue cosmologists. As we continue to explore the universe with increasingly powerful telescopes and innovative technologies, we can expect to make even more astonishing discoveries. By studying the universe and its origins, we gain a deeper appreciation for the interconnectedness of all things and our place in the grand cosmic tapestry.